All right, here we go again. Hey, so today we're going to look at some examples. These example involves both double bond and triple bond all in one molecule. Now, how will that work? And how are we going to name some of these things? Well, let's do an example. The best way to learn about this is to do many examples, and I have 5 for you today. So, let's draw with me. I have this bad boy right here. Okay, so as you can see, there's a double bond between this carbon and this carbon. But guess what? I'm going to put a triple bond right here. All right. So, because of that, how am I going to name this? You know, I'm going to make this a little harder and put a chlorine here and just put a nitro here just for the sake of having more to deal with. All right. I know you probably already have a lot to deal with, but just a little bit more is not going to hurt much. Let's put in those hydrogen. There we go. Here's all the hydrogens. And we are pretty much ready to name this thing. So, how do we start? We have to recognize that this has double bond involved and triple bond involved. Now, when you have multiple functional group involved, we have to go by something known as a priority chart, the importance chart, whatever they say in cognitive. Okay, I call it the priority chart. So, let's make a little P chart on the side of your note. Somewhere on the side, let's have something called P chart, and it increases as you move along. Okay, and we'll try to keep this P chart there for the remainder of the week. All right. So the higher up in the P chart, the more important that functional group is. So right now we know 3 functional groups. We know alkane, alkene, and alkyne. Now alkane as a subgroup is known as alkyl. Alkyl is actually not very important at all. In fact, it is one of the lower end of importance. Okay, we will continue to add to this later on. Now, alkene is actually more important. Now, is it more important than alkyne? It is. So, under this priority chart, we can see that alkene overrides alkyne, which overrides alkyl or alkane. So what that means is that alkene, being the more important group, should get the lower number in your longest carbon-carbon chain. So let me repeat that one more time. Okay, alkene, being a more important group than alkyne or even alkyl, should get the lower number in your longest carbon-carbon chain. Okay, so here's your longest carbon-carbon chain. No tricks. This carbon right here should inherit the lower number. Why? Because alkene takes priority over everybody else so far until we get into more important functional groups. So we'll see that later on. But in the meantime, make sure you know whenever you have alkene and alkyne in one molecule, this guy is, he calls the shots. Yeah. So you're going to number it left to right because you want that alkene to be number 2. Get it? All right, let's name this. We can name it the way we've been naming these side groups, okay? So alphabetically, we have 3-chloro. We have 6-nitro. And we have this long chain that comes up to be 7-carbon. Now, here's a problem. Before, we put a number in front, indicating where that double bond is, indicating where that triple bond is. But here you have a double bond and a triple bond. You can't say 2, 4. Well, is 2 the triple bond? Or is it 4 the double bond? We don't know that. So we're going to have to inherit a different system. Now this system you've kind of seen before. I kind of gave you a little snoop about it when we first took a look at double bond. So check this out. Now you're going to name the longest chain het. Okay, this is telling readers that your longest chain consists of 7 carbon. Now the thing is this, within those 7 carbon, at number 4 position, which means at the number 4th carbon and the 5th carbon, there exists a triple bond. We know that triple bond ends with -ine. Hence, we write 4-ine. Then we note the fact that in carbon 2, which is between carbon 2 and carbon 3, there's a double bond, so we end up with 2-ene. Now, let me ask you a question. Why did we do ine first, then ene? The answer is very simple. We always end our molecule with the most important group, right? When there's an alkene, the regular alkene we saw last week, we named it ene. We don't name it ane. When we had alkyne, we name it ine. We don't name it ane. By looking at the priority chart, 2 things has to be done. First, alkene must inherit the lowest number. Alkene must be what your name will end in. Alright, so this bad boy right here is 3-chloro-6-nitro het4-ine-2-ene. Sounds ridiculous, but that's what it is. Let's do another one. What if we have multiple? What if we have this? What are we going to do? As you can see, there's 2 double bond, 1 triple bond, and these side groups that we don't worry about anymore because we know how to name them. So, what are we going to do? Well, by convention, you do exactly the same thing. Name those side groups. Well, no, wait. What number? Left to right or right to left? Do you want a number 1 here because it's a triple bond right away? Or you want to have number 1 here so number 2 gets the double bond? Remember what I said? Alkene being the more important group. I want alkene to have the lowest number. Because he's the most important. Which means left to right at all time. Alright? Well, not all time, but this time. Because we want double bond to have the lowest number. If you were to go this way, you ain't gonna see no double bond until the 3rd carbon. Caught it? Okay, let's name this. Alright, so you have 4,4-dibromo, 2-chloro, 5-methyl. Alright, that took care of all the side group. Now your longest chain. Again, you're not going to put a number in front because that number will become a very confusing thing. Because what is that number indicating? Okay, what functional group does it belong to? So, oct. Okay, within this oct, you're going to name the triple bond because triple bond is less important than double bond. Where's the triple bond? Well, it's at the number 7 position, and we say 7-ine. Okay, here's where a lot of students make this very, very little mistake. At position number 2 and at position number 5, they're double bonds, but you're not going to say 2,5-ene, are you? No, you're going to say 2,5-diene. Be careful of this di. You don't want to die because of this di, right? Okay, that sounds cheesy, but okay. Ready for another one? All right, I'm going to clear this. I'm sure this is something that you can memorize for now. So let me just clear screen and let's do another one. I'm going to stop putting hydrogens in. I'm getting lazy. You're lazy too. I'm sure you don't want to put hydrogens in. So why don't you guys pause this video and maybe name this for me? How's that sound? I'm going to show you something. Actually, no. Yeah, I'm going to show you something. Okay. Done. All right. I'm not going to put the hydrogens in, but you know where to put hydrogens, right now. Because you're pretty, you have enough expertise to know how many and where you're going to put in hydrogens. I have a couple of things here. Okay. First, what is this? Second of all, can this be part of your longest chain? Because can you do that? Like that. Can you do that? Because if you do that, this is a side group, and I have no idea how to name a side group that looks like this. So one of the things that you have to keep in mind is that your longest carbon-carbon chain must consist of all the double bond and triple bond. All right? Because you selected this as your longest carbon-carbon chain, you would have no idea how to name something like that. Okay? So what if people say, hey, what if I have more here? Okay? Won't this make it like super long? Wouldn't it be the longest chain? No. No, because your longest chain has to consist those double bond and those triple bond, or else, even though if you can find something longer, that cannot be done. All right, so let's erase all of this and put this back. Now, second of all, now we've got that out of the way. What is this? This is not a propyl, even though there's 3 carbon, because in this case, you have a carbon right here, but this CH split into 2 CH3. It's not an ordinary propyl. Okay? It has a very special name. You will need to memorize this because when we do enough of these molecules, I'm going to put some of these things in every now and then to let you know that these are known as special alkyl groups. Of course, special alkyl groups have special names. We call this isopropyl. So whenever you see a carbon as a side group that splits into 2 CH3, we call that isopropyl. Alphabetical comparison wise, you use the I. So make sure you memorize that. There's actually three more, and I'll show you what they are as we move along. Okay, so there's just three more. Very simple. All right, knowing that that's isopropyl, let's name this. Okay, so hey, longest chain, right? Here's my longest chain. Where am I gonna go? Left to right or right to left? Because if I go left to right, I hit double bond right away. If I go from right to left, I also hit double bond right away. So what do you do then? Well, if there's a second double bond, which there is, you find where that is. And that should get the lower number. Well, look at that. So it looks like it's going to be right to left. No doubt about it. Here you go. All right. So, knowing that, we're going to name this. So that will be 3 isopropyl 8 nitro none. Okay. Triple bond first. 4 6 diene. And then 1 2 8 triene. So 3 propyl, 8 nitro, non 4 6 diene, 1 2 8 triene. Such a weird name. All right. Are you guys comfortable with double bond and triple bond all in the same, question? Well, let me give you some of the special alkyl group, okay? Let me just give them to you now, and then for the next couple of slides, I'm going to insert them in random places and see if you guys can figure it all out. So I have something like this. CH2, CH, CH3, CH3. If you see something like this, this is called isobutyl. Okay? Or you can see something like this. This is one of my personal favorite. Like that. This is called T-butyl. Okay, the T stands for tert. T-E-R-T. Nobody says tert. So most people call it T-butyl. And then you have this one. This one. Okay, this is called S-butyl. The S stands for sect. S-E-C. Again, nobody said sect-butyl, but they said S-butyl. Alphabetical comparison. I, T, and S. Okay, so these are some special side group that you need to be aware of, and there's no need to be afraid when you see them, but sometimes they may be there to trick you, so be careful there. Okay, be very, very careful there. So, here it is, okay? So for the next question, I might insert one of these things in and see if you guys can figure it out. All right, let me erase this board. Let's do another one. Okay. This should be enough punishment. So, pause this video. See if you can figure it out. Alright. Hopefully you figured it out. Okay, that's why you unpause, right? So let's take a look at how we're going to name this. Alright. There's a couple of problem here. Okay, not big problem. Okay, little problem. We know that this is a T-butyl. We know this is an isopropyl, and we know that this is a cyclopropyl. We know that. Okay, and we know that this is your longest carbon-carbon chain that consists of so double bond and triple bond. But, we have a dilemma here. Should I go left to right or right to left? Remember, double bond takes priority, and you want double bond to inherit the lower number. But, if you go from here, double bond is number 4. Go from here, double bond is also number 4. So we can't use double bond as a determining factor. Okay, what do? Well, you use triple bond as your determining factor, right? If double bonds cannot be determined because it's tied, well, let's look at triple bond because that will be the next in line. Makes sense. Well, hey, triple bond at number 1, going from left to right. But, triple bond is also number 1, going from right to left. So if you can't use double bond, and you can't use triple bond, hey, then you use alkyl groups whenever a side group came first. Just like what we've been doing in the very, very beginning. Right? So, side group, huh? Let's go from left to right. So 1, 2, 3, 4. So 3, we hit 3. 1, 2, 3. We also hit 3. Oh my goodness. Alright, then when is the second one coming up? 1, 2, 3, 4. Oh, 3, 4. Okay. 1, 2, 3, 4, 5. 3, 5, huh? 3, 4 versus 3, 5. Sure, you know the answer already. We're going to go this way. Right? And the name for this bad boy is 6 isopropyl. Okay. 3 cyclopropyl. Okay. And then 4 T-butyl. Oct. 1, 7 diene fluorine. I hope I got it right. You know I make mistakes, so those of you who are savvy, check my answer, please. Don't let me embarrass myself again. Alright, how does that sound? Great? One more. Okay, that should be enough punishment. Go for it. Pause. Alright, back. Let's take a look at how we're going to name this. Alright, here's my Cargus chain. Okay, And didn't really want to trick you this time. Double bond right away, huh? So looks like this is it. Carbon 1, 2, 3, 4, 5, 6, 7, 8. Oh my goodness, all the way to 10. All right. Alphabetical order. So what I have here is obviously 5 cyclobutyl. Okay. One of the things that you have to keep in mind is that cyclobutyl, it is the B that you use for alphabetical comparison. All right. What about this and this? Have you seen I? I is called iodo. Okay, just like bromo, chloro, fluoro. This is iodine, iodo. And this is, of course, isobutyl. So, iodo first. Okay. Then, isobutyl. Then methyl. All right. And then we have deck. Within this deck, where's the triple bond? Number 6, so 6-9. Where's the double bond? Well, number 1, number 4, number 8, 3 of them, huh? Triene. So, hopefully you guys are comfortable with that. And that's exactly what you guys got. Alright, I'm going to give you one more to do for homework. I actually have a lot for you to do the next day. So tomorrow I'm going to have like a 4-page worksheet all about double bond, triple bond, double and triple bond together, and see if you guys can figure that one out. Okay? And then we'll post the answers. But let me do one more with you. Well, I'm going to leave one more for you to do at home. So, and we'll take it up the next time we speak. Okay, so it's going to be looking like this. Let me just so long. Let's have one of these. Let's have one of these here. Let's do a triple bond over here, double bond over here, double bond over here. Yeah, that should be enough punishment, I think. And maybe we'll do one of these. I've seen one of these for a long time. All right, go for it, and we'll take it up the next time. All right, bye now.